All right, we're Math 200. We're looking at Chapter 6, 6.1 and 6.2 notes, dealing with rational functions. So when we look at rational functions, what we're talking about is we're talking about what x, when we talk about the domain, we want to know what values can x be, basically. So x can be any value except we can never divide by 0. So in this case, if I said x minus 3 cannot be 0, we would add 3 to both sides, and we'd say x cannot be 3. So x cannot be 3. If we want the longer version, if you're doing it online, they probably want like all real numbers except for 3. All right. Let's take a look at this one. It's a little tougher. We have 7x minus 2, and on the bottom we have to factor that in order to find the no-nos. Because right now x squared minus 2x minus 15, I don't know what x values would make it be 0. But we can find it by factoring. So if you take negative 15, you think of the suspects for negative 15, negative 1 and 15, negative 15 and 1, negative 3 and 5, negative 5 and 3. Any of those add up to be negative 2, that would be the last one that I wrote. So x minus 5, x plus 3. So now what value would make that be 0? That would be a 5, right? 5 minus 5 is 0. So x cannot be 5, and x cannot be negative 3. Simplify. Now this is different. This is different than domains. So these first two were domains. Number 2 was already done for you on the notes. That's why I didn't do that one. Number 3 or number 1 here, simplified. We're going to factor. So I can factor a 7 out of there. And then I divide that by 7. Divide that by 7. We get x plus 5. And on the bottom here, I can factor out an x. Divide that by x, divide that by x, and we get x plus 5. And now look, we got x plus 5, those cancel. So we end up with 7 over x. All right. Oh, I gotta go grab mine. I'll be back in a second. Left my notepad in the room. All right. 3PO, the TA, is holding my erasers and markers. 16. Okay. So then, on the next one, we got, where are we? On page 3. So number 2, we have x squared plus 3x minus 4 over x squared minus x minus 20. So we factor the top. That multiplies to be negative 4. So negative 1 and 4, negative 4 and 1, negative 2 and 2. It's got to be this one, first one. X minus 1, x plus 4. We factor the bottom. Negative 20 is negative 4 and 5, negative 5 and 4. It would be that one. X minus 5 plus 4. So now we've got both top and bottom factored, and now we look for any binomials that are exactly the same. In this case, the x plus 4s cancel. And so we're left with x minus 1 over x minus 5. You can leave your answer like that. That's fine. If you want, you can leave the parentheses on it. That's fine. I think online allows that too. So if you want to do it like that, that's fine. All right. Number 3. We've got, what, 2y squared plus 2 over y to the 3rd minus 5y squared plus y minus 5. So on the top, we factor out 2. So I'm going to factor a 2 out front, divide those both by 2, we get y squared plus 1 left hand side. And we do factor by grouping here. I'll do it underneath. Factor out a y squared, divide that by y squared, divide that by y squared. We get y minus 5, still a plus there. Factor out a 1, divide that by 1, divide that by 1, y minus 5. And now look, we got y minus 5 twice, so we can factor out a y minus 5. And we're left with y squared plus 1. So y minus 5, y squared plus 1. And boom, nope, those cancel. So we end up with 2 over y minus 5. That's my answer. All right, on the next part, we subtract, or not subtract, we multiply, which is not that tough when we're doing this.